Hi everyone. This lesson is about uncertainty calculations from experimental data. So let's begin with an example. Say for instance that I had a table and I measured the length of the table to be 1.43 plus or minus 0.01 metres, and I measured the width to be 0.87 plus minus 0.01 metres. Now I might want to know the perimeter of the table. So the perimeter of the table is twice the length plus the width. Straightforward enough. And we 1.43 plus 0.87. Now that's going to be 2 by, that's 2.30, and that comes to 4.60 metres. However, I'm really interested to know the uncertainty in this. Now, when I have added numbers together, I add the absolute uncertainties. These uncertainties here are the absolute uncertainties because they're in the same unit of measurement as the length and the width. They're both in metres. So in this case, if I wanted to know the uncertainty in the perimeter, well, the uncertainty in length is 0.01, and I add the uncertainty in the width, also 0.01, and because I doubled that addition, then I double the uncertainty. So 0.04 metres is the uncertainty. Now what's the best way to report the answer then? Well, the answer is 4.60 plus or minus 0.04 metres. So the main idea of this one is that when adding or subtracting measurements, you add the absolute uncertainties. So that's that one. Now what if we were to want to know the area of the table? Different calculation. Area of the table is the length multiplied by the width. So I'd need 1.43 multiplied by 0.87 to do the calculation. And I'll just pause while I figure that out. So that is 1.2441 square metres. Now that's not the final thing here. That's too many significant figures. Let's figure out the uncertainty in the area. Now for this one, we need to use the relative uncertainty. So it's the absolute uncertainty divided by the quantity itself. Now for this, we'll need the relative uncertainty in length plus the relative uncertainty in the width. So that was, remember, 0.01, and the length was 1.43, and the relative uncertainty in the width, 0.87. So we are always adding uncertainties together. Uncertainties always get bigger, not smaller, as a result of calculations. So I'll just figure those out. Okay, that calculation gives me a value of 0.018, and there are more digits on my calculator, but I won't write them down. That's the relative uncertainty in the area. Now, some people may express that as 1.8%. That's fine, it's the same value. Decimal 0.18 or 1.8% mean the same thing. Now, I'd like very much to convert this back into an absolute. So I multiply by the area. Remember that number was delta A over A, the uncertainty in over area. So when multiplying that through, I need 1.2441. You can see now why I didn't round any of that off, because I hadn't finished yet. And multiplying that through, So I have 0.023 as the uncertainty. Now this tells me that, and that's an absolute now, that's in square metres. Now, we usually only keep one significant figure in uncertainties, in absolute uncertainties, so that's the 2 there. I'll be looking at the 3 to decide how I'm rounding, and I'll round down. Now that is the second place, decimal place, so that will be the same place that we round off. So I will quote the answer here then. I'll say, therefore, the area is 1.24, rounded properly, plus or minus 0.02 square metres. And that's my uncertainty calculation when multiplying. When multiplying or dividing, we add we call these the relative errors. So it's the ratio of the absolute divided by the value itself. And that's for the width. Absolute error of the width divided by the width. Those become relative errors, and that gives us the relative error in the answer. So in our case, area. That's error propagation. Very brief introduction. Once again, adding and subtracting, add the absolute errors. If we were multiplying by a constant, so that number was not a measurement, that was a perfect number, if that's a doubling of the measurement, we double the uncertainty. Down here, multiplying or dividing by measurements, we add their relative errors. Okay, thanks for watching.